Hello friends, in this problem we have to find the Jacobian of xy with respect to uv. So here we using the property of Jacobian. Since we know that Jacobian of uv with respect to xy and Jacobian of xy with respect to uv, this is equal to 1. We know that the product of the Jacobian of uv with respect to xy and Jacobian of xy with respect to uv, this is equal to 1. So here first we find the Jacobian of given function uv with respect to x and y, and using this property we find the Jacobian of xy with respect to uv. So first it is given that u is equal to x square minus y square and v is equal to 2xy. So by the definition of Jacobian of uv with respect to xy can be written as del u upon del x, del u upon del y, del v upon del x, del v upon del y. Here first we find the Jacobian of uv with respect to xy. So by definition we can write the second order determinant, and this first row makes with partial derivatives of u with respect to xy, and second row makes with partial derivative of v with respect to xy. Now you can see here del u by del x, this is the partial derivative of u with respect to x. So differentiation of u with respect to x is 2x here, and differentiation of u partially with respect to y, this is minus 2y, and differentiation of v partially with respect to x, this is 2y, and differentiation of v partially with respect to y, this is 2x. Now we solve this determinant. Now we solve this second order determinant. So we get here 2x multiplied by 2x, we get 4x square minus 2y multiplied by minus 2y, we get 4y square. So this becomes 4 times x square plus y square. Now we using the property here, we get the solution. So we know that Jacobian of uv with respect to xy multiplied by Jacobian of xy with respect to uv, this is equal to 1. So we find here Jacobian of uv with respect to xy, this is 4 times x square plus y square multiplied by Jacobian of xy with respect to uv. So from here we can see that Jacobian of xy with respect to uv, this is equal to 1 upon 4 times x square plus y square. So this is the answer here. Thank you.